Okay, hello. Welcome to Unit 1, Lesson 1 of Geometry, Patterns, and Inductive Reasoning. We're going to start off with just a few definitions. A pattern, basically you're just going to define it as a repeated sequence. It's any kind of sequence that has unknown repetition. Inductive reasoning is a conclusion based on an observation. Now this observation can be a pattern, it can be something that you see happening in the world. We call that conclusion a conjecture. And then last we have a counterexample. This is something that's used to disprove a conjecture. So that's if we come up with something, but then all of a sudden we find a case that shows it's wrong, that case is called a counterexample. And we only need one counterexample to show that a conjecture is false. So let's start off by just practicing with some patterns. In this first one we see we have a triangle, a square, and a pentagon. Well, it looks like the sides are increasing. So what we're going to do is we're just going to say, what's the next thing? Well, the next thing is going to be a hexagon. So I'm just going to draw in a hexagon. Not a very pretty hexagon, but it's a hexagon. And please feel free to pause the video at any time to try some of these examples on your own before listening to me do them. So next we have 1, 3, and 5. Well, we go 1 to 3, that's plus 2. 3 to 5, that's plus 2. So the conjecture I'm going to make is that the next thing is going to be plus 2, which would be 7. This last example we have an arrow pointing up, an arrow pointing to the right, an arrow pointing down. Well, looks like there's only one other way for the arrow to go, and it looks like it should point to the left. Next, let's complete these following conjectures using the words odd or even. So any of our answer is going to be just it's odd or it's even. So we're talking about numbers here. And again, please feel free to stop the video to try these on your own. So the sum of any two even numbers is blank. So to do these, let's experiment with some numbers. So any two even numbers. Well, I know 2 is even, 4 is even, sum means plus, 2 plus 4 equals 6. Well, 6 is even. Now we can't just try 1, we got to try 2, maybe even 3. And it says any. So let's try some bigger numbers. Let's try 32 plus 44. Well, that equals 76, which is also even. So just looking at this, it seems that the sum of any two even numbers will be even. Next it says the sum of an odd and an even number is, so it looks like we're adding an odd number and an even number. So let's just start off with the first odd number and the first even number. 1 plus 2 equals 3. Okay, so that's odd. Let's try the next pair. Let's try 3 plus 4. That's 7, which is also odd. You know what, let's try one more just to be sure. Let's try 5 plus 6, which is 11, which is also odd. So it looks like our conjecture is that it is odd. Our last example says the sum of the first n odd positive integers is. Now, we're not saying how many. That's what that n means. It means we can take 2, we can take 1,000, as long as they are odd positive integers. So that means 1, 3, 5, 7, so on and so forth. So what happens no matter how many of them we add up? Well, let's just start at the beginning. Let's do 1 plus 3. Well, 1 plus 3 is 4. That's even. Well, let's add in 5 now. Plus 5 is 9. Plus 7 is 16. So it looks like we go even, odd, even. So what I'm going to say here is the pattern seems to be even, odd. Okay. In this slide, we're going to provide some counterexamples. Counterexample, again, is just one example that shows that a conjecture is false. So here we have 3 conjectures, and we want to show that they are false. The first one says that all prime numbers are odd. Well, we have to think about what's a prime number. Prime number is any number that's only divisible by 1 and itself. Well, let's just start at the beginning. We have 1, which is technically not prime, so we go to 2. Well, 2 is only divisible by 1 and 2, but is 2 odd? It's not. Therefore, we see that our counterexample is the number 2. Our second example says the sum of 2 numbers is always greater than the larger. That means if we take any 2 numbers, they can be odd, they can be negative, odd, even, negative, positive, doesn't matter. They have to be bigger. When you add them together, that number has to be bigger than the larger of the 2. So let's say we take 1 and 3. 1 plus 3 is 4. Well, 4 is bigger than 3. But let's look at this. What's negative 2 plus 1? That's negative 1. Is negative 1 bigger than 1? No. Therefore, this is a counterexample. The last one says the square of a number is always greater than that number. Remember from algebra, a square is whenever we take that number times itself. So like 2 squared equals 4. Well, 4 is bigger than 2, so it works for this. So that's a positive number, so I think it might work for all the positives. Let's try negative. Let's try negative 3. Well, negative 3 squared is 9. Well, that works. But what about a number that's neither positive or negative? What about 0? Well, what's 0 squared? 0. So 0 is not greater than 0. Therefore, 0 would be our counterexample.